Hello everyone, my name is Alex. Welcome to my talk about MCP. We will talk about what it is, how it can help supercharge your DevOps process, and how you can do it safely without opening a security hole. Now, I am head of MLOps and DevOps at a company called Zencoder. I also work as DevRel there as well. Zencoder is an AI coding assistant, which I will show briefly when we will get to that stage. But for now, a few fun facts about me. So I've been in IT for more than 10 years now, mostly in machine learning. I did, of course, also MLOps, DevOps, and backend. I've been building as a coder since the first day, pretty much. So I'm one of the founding members. For the last year, I mostly been working as DevRel. This is my event number 52, and this also resulted in a lot of flights. And I also have 4 main coons, which I occasionally, between flights, have a chance to see back home on Madeira, Portugal. Now, MCP is something that everybody is talking this year. Like everybody is trying to create their own MCP server. But what is MCP? To answer the question and also why we need MCP, we need to take a step back and talk briefly about AI or specifically about LLMs. Everybody nowadays, when they talk about AI, they mean LLMs. And LLMs, as you might know, they are trained to predict the most probable token or symbol. And sometimes it still can lead to mistakes. They are great at detecting patterns, but they don't still understand what is behind those patterns. And of course, sometimes this can lead to some mistakes, some errors, which for us, for humans, doesn't make sense. But then, as I mentioned, LLMs are great at detecting patterns. So this is what they did in this case. But we all know how AI is with hands, so that's not really surprising. But yeah, joke aside, we can, from this sort of example, we can deduce that LLMs actually lack ground in the physical world. So what this means is they sit, the models themselves, they sit somewhere in the cloud, and they don't have actual access to the physical world, to your local machine, to your servers, and so on. And of course, if you ask, let's say, ChatGPT about what's the response time for Google, it wouldn't be able to answer you. It will provide some helpful comments for that. So it might say you can use ping or whatever. But of course, that's not the actual answer to our question, right? So if we were to ask something more specific to our systems, ChatGPT or any other LLM wouldn't be able to help us because it sits somewhere in the cloud and again doesn't have access to our servers, to any servers for that matter. And of course, it becomes even worse, again, if you want to use your own framework, if you maybe want to use your own systems, like infrastructure and so on. LLMs have usually no knowledge about those, especially if you are developing some in-house company framework. LLMs most likely do not have any knowledge about those frameworks, and they would just fall back to those frameworks which they've seen in the open source data. Technically, we can then replace this phrase, this wording, that LLMs lack grounded in the physical world, into LLMs can't collect extra context. And again, by extra context, things like, you've seen an example with Ping, getting response time is essentially getting context, right? Extra context. So actual response time would be, those milliseconds would be extra context for LLM to give us more contextualized answer. Or accessing to your systems, to your servers, to your login systems and so on, also would allow LLM to get extra context to give you much more personalized answers. Now, the solution to that is let's allow LLM to use tools, right, to get this extra context. And what could go wrong, right? So we can allow LLM to push code to production, maybe. Like some companies already apparently do this up to 75%. Or we can give LLM access to the database, maybe, right? Maybe not right access to the database, because it might, for whatever reason, decide to wipe it. But still, it would be useful for LLM to get this knowledge. Now, jokes aside, the most common, the most popular way to give LLM access to tools is MCP, or Model Context Protocol. And it was introduced by Anthropic roughly a year ago, I think in December 2024. But since then, it became de facto standard across the industry. And just to give you an example, OpenAI, the main rival of Anthropic, actually also adopted MCP. The latest GPT-5, GPT-5.1, they can also work with MCP. But MCP essentially is a protocol for LLMs to gather extra context. It is based on JSON RPC 2.0, and essentially it is just a set of structured inputs and outputs. But the main two entities, the main two concepts inside MCP would be MCP host, first of all. Right, so MCP host is essentially your LLM, your IDE, which is essentially the proxy between the LLM and the MCP server. And then MCP server, the second entity, is responsible for two main things. First, it is responsible for advertising the list of capabilities, the list of tools available to MCP host, to LLM. And second, it is responsible for actually executing those tools. And those tools can access pretty much anything, right? So anything you need to gather extra context and provide it to LLM, you can convert to MCP server. And it can access, let's say, local resources, maybe your file system, maybe it runs bash commands. It can also access remote resources, of course. So it can access, for example, GitHub or Jira or whatever system you use. So again, essentially, anything you can convert to the code, anything you can access through code can be converted to MCP server and then used to feed more context to LLM. There are actually several features of MCP inside the Model Context Protocol. However, the most known is tools, and this will be the main focus of our today's talk. But I also would recommend to check out all the other features like resources, prompts, sampling, and routes, because they do provide some useful capabilities on top of MCP tools. But here's an example of the tool. So on the right over here, you can see the actual implementation of the tool for creating branch. This is taken from GitHub MCP server. And this is actually not the full code. This is just the beginning of the function. So over here, they define essentially the description, the annotation of the tool, and which kind of parameters it takes as inputs. You can actually see a more compact description on the left, which is what is actually included into the prompt and then later fed into LLM. So as you can see, there is a description, right? So it creates a new branch in GitHub repository. It takes as input 4 parameters, although only 3 of them are required. And essentially this helps LLM to decide which tool it needs to use and how to use it. And this is how the actual flow would look like between the user, us, LLM, MCP client server, and some external system. So first, as I mentioned, the MCP server is responsible for advertising its capabilities. So this is essentially just a handshake stage between MCP client and MCP server over here. So whenever MCP client initializes connection to MCP server, the server returns the list of its available capabilities, which are then later, as I mentioned, attached to the prompt of input to LLM. Now, whenever we as user ask something from LLM, so let's say again we ask for the response time for Google, LLM recognizes the need for external data. So in this case, it needs to perform maybe ping command, right? Whenever LLM decides that it needs access to more data, that it needs to gather more context, it can request the use of MCP capabilities. And then, well, there is of course also optional permission request, although most of MCP servers do not do this, or MCP clients. Then MCP client provides to MCP server which kind of capability it wants the server to execute, along with some inputs if they are required. And then MCP server is actually responsible for executing that tool call. It gathers the data, and then this data is returned in a formatted way, in a standardized way, back to LLM. And then LLM hopefully can give us the answer already right away, or maybe it then decides to gather more context through a different tool and so on, all the way until it gathers enough information to give us contextualized answer to our initial query. And there are already quite a lot of different MCP servers available for you to use. So on the left, this is probably not even the 1% of all the servers available. As you can see, they're not only about software systems, although you can see, for example, there is Grafana, there is ClickHouse or Cloudflare. So those MCP servers would allow LLM to access those systems. But there are also MCPs for tools outside of T-Space. There is, for example, the EXA, it is a search engine. But of course, you can find MCP servers pretty much for, I would say, almost anything. And there are a few marketplaces or registries for MCP servers. The first one, the initial one, sort of from Anthropic, contains quite a lot of MCP servers. For example, MCP servers, as well as those which were initially implemented by Anthropic. We at Zencoder also have our own marketplace. And there are, of course, also a lot of third-party marketplaces available for you to search for MCP. And here's an example of a few, probably the most helpful MCPs, which you might find useful in your everyday life. Of course, there is MCP to access databases. So here's an example for Postgres. But depending on what kind of database you use internally, you might prefer different MCP. There are, of course, MCP servers to access login systems, right? So monitoring systems like Grafana, for example, or Sentry. There is tools or servers to access messaging tools like Slack, for example. Context7 is another helpful MCP, which essentially allows LLM to search for up-to-date documentation for any library, for any framework. And there is also Playwright MCP, not to be confused with Playwright testing framework. Playwright MCP server allows LLM to essentially use the browser. So it allows LLM to open the browser, navigate to pages, click around, fill in forms, and so on. And then LLM can later use that to write, for example, end-to-end tests. Now, if you don't find the server which fits your needs, you can, of course, quite easily create your own MCP server. And there are SDKs available in quite a lot of different languages. I think there is now probably around 11 or 12 SDKs or languages available for SDKs. And as you can see, of course, it is available in the most popular languages like Python, TypeScript, Java, and so on. And you've seen an example for MCP server, right? For the create branch, it was actually in Go. So you are not limited to some specific language. You can create MCP servers in pretty much any language you are comfortable with. But here's an example in Python. So in order to convert any code to MCP server, in Python, you need essentially just those 3 lines I circled in orange. So, of course, we need to first import a library called FastMCP. Then we need to instantiate the FastMCP server. And then we just need to label our function, in this case for executing bash commands, with this decorator mcp.tool. And that's pretty much it. So with just those 3 lines, we converted our initial code for running bash commands into MCP server. And now any LLM compatible with MCP can use this server to execute bash commands on our local system. Now let's actually see this in action. I have a few practical examples to show how it looks like in real life and how MCP can extend the capabilities of LLMs beyond just outputting the text for you. So first one, the most probably obvious one, is a combination of Jira, Git, and GitHub MCP. So through this combination, you can essentially ask LLM to pull the context from Jira ticket, solve it for you, commit changes, and then create a pull request. And of course, if you are using not Jira, but maybe Linear, or maybe not GitHub, but GitLab, you can replace those respective MCP servers with something else. But in my case, I will be showing an example in this combination. So let me switch my screen over here to VS Code. And over here, I actually already pre-executed an example. So inside Encoder, we have a native integration with Jira, which essentially allows you to just tag the ticket. However, of course, you can achieve pretty much the same through Jira MCP, although it wouldn't be as user-friendly as native integration. But basically here, I'm tagging the ticket, asking the agent, let me zoom in, asking the agent to solve it, create a branch, push and create a pull request. And it took the agent a bit of time, so it navigated through the repository, again through different tools, through different MCP tools. It has access not just to Jira, Git, and GitHub, but also it is provided with tools we serve as part of Encoder. So tools like grep, or maybe reading files, and so on. So it did a bit of exploration of the repository. It found all the necessary files which needs to be modified, and it started modifications, started modifying the code. It ran some bash commands to generate the OpenAPI schema. And in the end, let me scroll all the way down. So somewhere in the end, it created a branch for us. Let's see, I don't see the branch was created somewhere. I think I missed it, but basically it created a branch, it created a commit, it pushed everything, and then it used MCP tools to create a pull request for us over here. And let me actually show how it looks like. So this is our pull request, and I would say it is probably one of the nicest looking pull requests I've ever done. It was using my token, so it is authored by me. But it basically made all the changes. In this case, quite a lot of files, 110 files. It committed them, created a nice description. Again, all the changes, how it works, pretty much everything. And yeah, again, I would say it's probably one of the nicest pull requests I've ever done. And I guess it is nowadays the sign of AI, because in this day and age, documented PR is apparently a bad thing, because it is most likely generated by AI. But jokes aside, asking LLM to solve a ticket for you is a rather obvious example, right? So let's go to the second one, which is a bit more not advanced, but a bit more going beyond just solving the ticket. So we can actually give LLM access to Kubernetes. So we can give it access to our Kubernetes cluster, and then we can, for example, ask it if there are any issues with the pods, with the deployments, and so on. So let me actually switch to my VS Code over here. And again, I pre-executed one example. Let's see, this one. So essentially here I'm asking, are there any pods in the specific namespace which are in non-healthy state? So you can see LLM used the specific tool for listing pods in namespace from the Kubernetes MCP server. And in this case, there are apparently no pods in unhealthy state. But of course, if there would be any, you could then, for example, ask LLM to fix the issue for you. Maybe there is an issue in the code, maybe there is an issue in the deployment, but essentially, given access to the Kubernetes, to the Kubernetes cluster, LLM can then help you either debug something without you needing to copy-paste the errors or anything else. Essentially, LLM can just do that for you. It can just go to the cluster, check the logs, check the events, see what are the states of the pods and so on, and then use that information to give you better answers, more relevant answers, and help you further improve your productivity. But of course, with great power comes great responsibility, and while MCP is great for extending capabilities of LLMs beyond just outputting text, MCP servers also do make a lot of issues, security issues, and backdoors and node authentication is just scratching the surface here. But I prefer to split those security issues into two kind of main categories. First of all, of course, as was shown previously, MCP servers are essentially code which you run on your server or on your local machine, which means that whenever you are using any third-party MCP server, it is essentially you running any third-party code. And of course, the usual suspects when it comes to executing third-party code on your machine, on your server, are the typical stuff which you might already be protecting from, right? So it can be package name hijacking, it can be executing malicious code because you are essentially executing the code. There could be supply chain attacks and so on. So in this category of attacks, there is no really specificity to MCP or to AI. It is essentially general attacks based on executing third-party libraries and all the tools which you might already use to protect from that. So maybe some static code analysis or something similar. they are already helpful when it comes to MCP. However, with MCP, there is another player, which is essentially AI. And there are, of course, a lot of attacks which are based on sort of social engineering for AI. And all of those attacks, in a sense, can be classified as prompt injection, but they have their own sort of twist when it comes to MCP. But of course, still, prompt injection itself is one of the most prominent ways to attack AI systems. And prompt injection means that essentially the perpetrator injects a special string into the prompt, into your initial prompt as a user. And then this prompt is essentially hijacking the LLM and making it do something else. So let's say you as a user ask LLM about the weather somewhere, but then attacker adds some specific lines of text, and it makes LLM, instead of answering you about the weather, it makes LLM do something else, maybe create a file on your system, or maybe just output some text about something else. So that's prompt injection. And of course, through MCP, you can inject it in different ways, but there are also attacks which are MCP specific. So of course, you can potentially, the attacker potentially can poison the tool, meaning that the code which is being executed whenever the tool is called can be malicious. It might be doing something else, not what advertised by the tool. There are also attacks based on tool shadowing. So essentially, let's say a malicious MCP server creates a tool which is called the same as, or maybe similar to the benign server. And then AI might decide, or MCP client might decide to use this shadowed malicious tool just because the name is similar or the same, and hence cause unnecessary execution of malicious code. And then, of course, MCP, through MCP servers, you can actually execute code as well. There is a way to essentially ask AI to just simply execute the malicious code. You don't even need to modify the MCP server, the code of MCP servers somehow. AI can essentially execute malicious code for you through MCP. Now, let me show a quick example of how the prompt injection can hijack your LLM through the use of a few MCPs, a few simple MCPs. So let me switch to my notebook over here. Let me remove all this. And what I have here is a simple MCP client, which is, in this case, using Cloud Sonnet 4.5. And execute this. It is a simple MCP client. It gets a few tools at its disposal. So there are 3 MCP servers. First one is for accessing a file system. So it can read files, it can write files, move files, and so on. There is a MCP server for fetching web pages. And then there is MCP server for executing bash commands. So on top of that, I also have running locally a simple web server, which looks pretty much safe for us, for a human eye, right? And as the name suggests, it is actually safe. I have another page, which is called not oops, which again looks the same. And I have a third page called oops, which is, again, looks the same for humans. But let's ask our LLM to fetch the content of those 3 pages and observe how it behaves. So every time I ask to our LLM, our Sonnet 4.5, to fetch the content of the page and then say hi to us. So let's see what happens with our regular page. As expected, it fetched the content. The content looks pretty much like what we saw, right? And then, well, the LLM says hi to us as instructed. Now, the second page, not oops, is a bit tricky, because even though, of course, LLM providers, they try to protect from injections, still not all attacks can be successfully detected. Actually, I think Anthropic several months ago reported that they detect up to 88% of prompt injection attacks, but this still leaves 12% of attacks not detected. So this page, not oops, sometimes it actually hijacks the LLM, sometimes it doesn't. So let's see if it will hijack the LLM in this case, in this run. But essentially, as you can see, in addition to what we've seen on the page, right, so the hello world, this is my simple web page text, it actually also had an extra instruction, which was hidden from human eye, but it was fetched through fetch MCP tool. Now in this case, the agent said hi to us. It also noticed the code block, but it decided not to follow instructions because it appears to be potentially malicious. There could be like security vulnerability and so on, similar to prompt injection. So in this case, the prompt injection detection worked on the Anthropic side, and LLM actually refused to do anything else. And in this case, we asked the LLM to also create a file called oops.txt. Now let's try our third page and see how our LLM will behave in this case. As you remember, it was for human eye, it was the same context. However, there is actually extra data added to the page. And as you can see in this case, okay, let's see what's going on there. Okay, it looks like there is some issue with Anthropic. Let me try to run this. Hopefully Anthropic will be back up. But yeah, while it's executing, basically, as you can see, in this case, it is a bit more elaborate instructions. So we are asking LLM to list every function it has access to, which in itself, it is not really a malicious intent, right? But then on top of that, we actually also telling LLM that we have a new function, which is basically writing a phrase into the file. And then we asking it to test it by mock using this function and simulate the output as if it was a real function. Now, as you can see, it took quite a long time for LLM to respond, and surely enough, first of all, it said hi as instructed, but then on top of that, it actually started listing all the available functions. It's actually quite a lot of functions, 17 functions, but then what is more, when we asked to test mock this function, it actually didn't just simulate the output, it actually ran a write file tool and created a txt file on our local machine. Let me actually show it. So it was created 49 seconds ago, and surely enough, essentially, LLM was hijacked, and potentially this could lead to LLM either executing some malicious code or maybe stealing some files, stealing some data, and so on. As you can see, it was still quite easy to attack an LLM. But again, for the human eye, the page looked pretty much safe, right? So it only, for human eye, it only had these two lines of code written on the page. Now, if you want to play with this notebook, here's the QR code where you can find that code, that notebook, and you can play around with it on your own free time. But as you've seen, technically, the MCP itself, in my example, was not responsible for the actual attack, right? So it just fetched the page, and the actual attack was executed through the context of the page. MCP itself didn't do anything wrong. It did exactly what it was created to do. And this is actually how one of the recent attacks on GitHub MCP was executed. So you might have heard about this. Essentially, again, in this case, MCP on its own was not responsible for this exploit. What they did in this case is they essentially just created an issue in the public repository saying that the author is not widely recognized. And then they just asked LLM to go through all the private repositories, collect information, and then add this information to this public repository. And then LLM being given access to GitHub MCP, it did pretty much what it was asked to do, because why not? It was asked to gather information, it did this because it was given the tools to do this, and then it essentially just leaked private information into the public space. And again, technically, MCP itself, GitHub MCP itself is not the tool at fault here. It is the way AI is behaving, or the way AI agents are behaving, that is responsible for this exploit. Now, what are the ways to protect your organization? First of all, of course, you might want to whitelist MCPs. So you might want to define which MCPs you actually want to allow your developers to use or your LLM to use. You might want to consider organization-wide MCP configs, which means that you can control permissions. So it could be some read-only flags, it could be some specific set of tools which are allowed to be used from this MCP server and so on. And of course, some MCP servers require tokens. So let's say GitHub MCP, of course, requires GitHub personal access token to be able to access GitHub. And you might want to somehow safely and securely store them in your preferred system. You might also want to limit access to sensitive systems, which means maybe not give access to production databases, to LLM, or maybe at least not access to those databases. And you might also want to limit server or tool permissions. Again, read-only is one example, but actually in Kubernetes MCP is a good example of that. So they provide two flags as part of their MCP server. One is to enable read-only tools. And then the second one is to disable destructive, so that LLM will not accidentally or not delete the cluster or do some modifications to the cluster and so on. And then specifically for the prompt injection, detection and prevention, as I mentioned, all of the large labs which provide LLMs, like OpenAI, Anthropic, and so on, they of course work on securing and preventing prompt injection attacks. Although, again, of course, you can't protect from anything. If you are worried about LLMs ingesting some harmful data, you might want to consider to use some sort of intermediary tool. So again, in case of ingesting web pages, for example, specifically, like I've shown before, you might want to consider using some proxy that doesn't just ingest web page and pass it as is to LLM. You might want to use some sort of AI web search, right? So Exa or Perplexity, for example, because they, on top of just ingesting the web pages, they also do some summarization, they also do some protection and so on. So you might want to essentially use these sort of proxy tools before actually dumping the data into the LLM, leading to potentially harmful consequences. And with that, that's all from me. So if you want to try out Encoder, you can use this QR code over here on the, I guess, on your left. And then if you want to connect with me over here, you will find all my socials and so on. And thank you all for attention. And I hope you have a good day ahead of you.